Okay, we will solve the problem 1.5 of Griffith third edition Introduction to Quantum Mechanics. Problem 1.5 is consider the wave function. This is time dependent wave function. Remember that. Psi of x and t is equal to a e power minus lambda modulus x. This is modulus x. E power minus I omega t, where a, lambda, and omega are positive real constant. Then normalize this. There are three sections. First one is normalize the wave function. So for normalization, um, integral from minus infinite to plus infinite modulus I squared dx is equal to 1. Remember that here you have modulus x. So even if it is negative sign, it will become positive. So I am changing the limit because everything is positive. I am changing the limit from infinite to 0. So it will be always positive. I can remove this modulus x is just x because we are dealing with only positive region 0 to infinite. That scaling factor 2 automatically will come. So this integral must be equal to 1. So if you integrate this exponential 2 lambda x, then you will get e power minus 2 lambda x divided by 2 lambda. Limit is 0 to infinite. When upper limit, if you apply upper limit, it will be 0. If you apply the lower limit, it will be 1. So minus 1. Already you have minus 2 lambda. Here you can cancel this 2 as well as this 2. I, and also this minus minus will become plus. So a squared over lambda is equal to 1. That means a is equal to square root of lambda. Now the next question is determine that is section B is determine the expectation value of x and x squared. The expectation value of x by definition is equal to minus infinite to integral between minus infinite to plus infinite x modulus I squared dx. Naturally, this modulus I squared is even. Here you have add. So this add integrand between symmetrical limit will become 0 because this is add integrand. So what about the expectation value of x square is by definition minus infinite to plus infinite x square modulus I square dx. So psi is e power minus 2 lambda modulus x. But what I am going to do is I am going to take only the positive direction 0 to infinite. Naturally, one multiplication factor 2 comes here. So this is 2a squared, this wave square of this wave function. So this will become e power minus 2 lambda x. Of course, you have this x squared and dx. If it is of this form, that is, you can see integral between 0 to infinite xn e power minus alpha x dx. Using payment technique, kindly watch my video on payment technique of integration. So this is 0 to infinite x power n e power minus alpha x dx is equal to n factorial divided by alpha n plus 1. Here n factorial n is 2, you can see, because x power n is 2, this is n, and this is alpha, 2 lambda is alpha. So if you apply this expression, you will get 2 factorial divided by alpha plus 1. Alpha is 2 lambda, n plus 1 is 3. So that's what I have written here. And now this 2 lambda, this a squared is, you know, a is equal to square root of lambda. Just now we have seen. Then a squared is lambda. So now you can cancel out this 2 lambda with this 2 lambda cube, which will become 2 lambda squared. So you can 2 factorial is 2 here. 2 lambda whole square, 2 lambda whole square, 2 by 2 lambda whole square, 2 by 2 lambda whole square will become 4 lambda squared. So this will get cancelled. You will get 1 over 2 lambda squared. So expectation value of x squared is 1 over lambda squared. Now section C is find the standard deviation of x. Sketch the graph of modulus psi squared as a function of x and mark the point x plus sigma and x minus sigma to illustrate the sense in which sigma represents the spread. So, in spread in x, what is the probability of particle would be found outside this range? So, first we will find the sigma squared. Sigma. Sigma squared is by definition expectation value of x squared minus expectation value of x whole squared. This is 0. So this will become 1 over 2 lambda squared, because we know the expectation value of x squared is 1 over 2 lambda squared minus it is 0. So you will get sigma squared is 1 over 2 lambda squared. Then sigma is naturally you take square root. Square root of 2. If you take square root of lambda squared, this will become just lambda. That is sigma is equal to 1 over square root of 2 lambda. Then what is the probability inside the sigma, plus or minus sigma? So you integrate between, that is probability modulus x is uh, less than or equal to sigma. So minus sigma plus sigma limit modulus I squared dx. So you can see this is uh, as usual. This wave function is a e power minus lambda modulus x. If you square it, a squared e power minus lambda modulus x I am removing, because I am going to take only the positive direction, that is 0 to sigma. So naturally the modulus x will get removed. This will be yes, simply x. So naturally the uh, multiplicative factor comes in outside the integral. So this can be as usual lambda squared is a squared is lambda. So 2 times lambda, and if you integrate this, you will get e power minus 2 lambda x over minus 2 lambda. So if you apply the upper limit, what you will get? You will get e power minus 2 lambda sigma. Remember that this is minus. So e power minus lambda sigma will become minus, because in the numerator you have minus. Of course, this 2 lambda will get cancelled. So minus is there. Then for lower limit, this is minus 1. Already there is one minus. This will become 1. So 1 plus 1 plus 1 minus e power minus 2 lambda sigma. So what is lambda times sigma? You know lambda, you keep lambda as it is. Sigma we have seen 1 over square root lambda. So this lambda will get cancelled. So you will get this 1 minus e power 1 minus e power lambda. You will get lambda, because here 2 is there. So this term lambda sigma is equal to square root of 2. Then 2 over square root of 2 is square root of 2 minus square root of 2. 1 minus e power minus square root of 2. This is inside the sigma. What will be the outside the sigma? Then outside the sigma is this is the probability inside. Then outside will be 1 minus this. So 1 minus this one. E power, if you subtract, then e power plus minus square root of 2. So this will become 1 will get cancelled. This will get cancelled. So you will get simply the outside the sigma range, you will get e power minus square root 2, which is equal to 0.24. You can see this is the 0.24. If you draw the graph between minus sigma to plus sigma and modulus psi squared, what will happen at modulus psi squared? The value is simply lambda. Lambda is the maximum value. That is a squared. You know the wave function. Square of the wave function is a squared e power minus lambda modulus x. Of course, 2 will come because you are squaring it. Oh, okay, I will rewrite this. So the wave function is a squared e power minus 2 lambda x modulus x. So what will happen when x is equal to 0? This will be 1. So you will get the a squared. A squared is lambda. So maximum value is lambda, and the distribution spread is 0.24. So here it is 0.24. So we have find the solution for all the questions. Thank you very much for watching my video and supporting me continuously. Thank you very much.